Hi, this video is the 10th of my line of linear relations videos, and I'm going to try to go through this as quickly as possible, but I've got a few examples I want to do regarding graphing linear relations and determining equations from the graphs. Okay, so first of all, we're going to start here. We've got this equation, y equals 8 minus 3/5 x, and we're accustomed to seeing the general form, either y equals mx plus b, where we know that the m indicates the slope of the line, and the b indicates the y-intercept, and of course that's including the sign. I always like using y equals b plus mx, because if you're ever graphing a line, which we're going to do right now, I always start with the y-intercept. You start with a point that you know, and then you count out the slope in addition to that. Okay, so I'm going to start here, and we see what y equals 8 minus 3/5 x. Well, I know that the 8 is the constant, and so that is the y-intercept. And so I can identify on the y-axis here 8 being the y-intercept. So I plot a point right there. The next step I'm going to do is I need to find another point on the line, or another few points. It doesn't really matter, but I need to find at least one more point on the line so I can draw the line. So if I were to take a look at this, the equation again, we see that the slope is, and it's including the sign, it's the coefficient of x. So slope never includes the x itself. The x is the number of units that you would move along to the right in order to determine the next value of y. So the slope itself is negative 3/5 x. So I'm aware that slope, a way of looking at it is we can say rise over run. Okay, and we know that's delta y over delta x, so the change in y over the change in x. And that's all I really need to know in this case. I don't need to know the other formula. If we were using points, we could use that the third formula that we know for determining slope to determine the slope. But because we're going from this equation, we don't really need that. So I know that the numerator is the rise and the denominator is the run. Okay, so the rise is the change in x, sorry, the change in y, and the denominator is the change in x. So what I always like to do is I always like to say, just for consistency, I always say that we always run to the right. Always run to the right, and then we don't get confused. Okay, so you just stick with that. Just like we read, just like we write, we go from left to right, we always run to the right, and that'll keep a few things more consistent. Okay, and in that, if we know that along the x-axis, that to the left of the y-axis is negative values, and to the right of the y-axis are positive values, then this negative sign, I'm actually going to consider that being up here with the y. And then, so technically, I've got the equation y equals 8 plus negative 3 over 5x. So that negative is now in the rise, that's in the delta y. And that tells me now that, and if we are familiar with the values along the y-axis, any values above the x-axis are positive, and any values in y below the x-axis are negative. So if I know that this rise is negative 3, then I'm going to start at the 8, and I'm going to count down 3 units. So I'm going to go down 1, 2, 3 units. So I'm going down 3. So that's the negative 3. And then from there, I'm going to run to the right 5. I'm going to go 5 units to the right. So I'm going to go 1, 2, 3, 4, and 5. Okay, and of course, we're not just counting boxes that are on the grid. We have to use the scale that we see on the axes, okay, in both cases. So once I've gone from the positive 8, I've gone down 3 to the right 5, I'm going to place another point here, because that tells me, if that's the slope of the line, negative 3 over 5, that tells me if I start at this point, which is the y-intercept, and I know that the y-intercept indicates where the graph crosses the y-axis. So that means that this point is on the graph. It's going to be on the graph of the line. If I use the slope of the line and I go down 3 and to the right 5 for this particular slope, I'm going to land back on the line again, because the slope of the line will follow that trend of negative 3 over 5. So I've now found a second point on the line, and now all I have to do is I just have to connect those and extend the line. So I'm going to start at the point that I know, this 8, the y-intercept of 8, and I'm going to go through the next point that I see there, which is that point there. And then I'm also going to do the same thing, but I'm going to start up here and go in the opposite direction, because I want to extend the line. So the line would then go, and there's arrowheads on both ends of the line. That line is going to go all the way through. So from that point 0, 8, there's the y-intercept 0, 8. And this point is the next point on the line. And we see that this point is 5, which makes sense because we're going 5 units to the right when starting at 0 in the x direction. And we've gone down from 8, we've gone down 3. So that point is 5, 5. Okay, and then there are other points in the line. If we were to do this again, if we went down 3, 1, 2, 3. Notice we're counting down spaces and not actual lines. And so we go to the right 5, 1, 2, 3, 4, 5. We land back on the line one more time, and then this is the point 10, 2. Okay, so we've gone from the y value of 5, we've gone down 3 to the y value of 2, and from the x value of 5, we've gone to the right 5 to the x value of 10. Okay, so all these points and many more, because the line is infinite, as seen by these arrowheads, the lines go on forever in both directions. We will be able to find infinite number of points on the line following this trend, starting at 0, 8. We could even go in the opposite direction, but I prefer just to run to the right to kind of keep things consistent. Okay, and that's how you're going to graph a line from an equation. Okay, I'm going to speed things up a little bit here. We're going to go to the next example here. We're starting with y equals negative 5 minus 3x. And so now, of course, we still know that this is y equals b plus mx. Okay, the slope here is negative 3. That's m. And the y-intercept is, the b is negative 5. Okay, so now the last example, we had a fraction for the slope, and we knew the rise over run. Okay, so it's always going to be a fraction rise over run. But in this case, our slope is negative 3. Well, that's not a fraction. Well, actually, yes, it is a fraction. We know that any whole number will always have a 1 underneath. So now we've changed this integer, not a whole number, sorry, this integer of negative 3, we've changed that into negative 3 over 1. So now we know the rise is negative 3 and the run is 1. And we're going to run to the right. And because the slope is negative, we're going to be rising down, in this case, 3 units for every 1 unit we run to the right. Okay, and in this case, the y-intercept is negative 5. So we're going to start at negative 5. And so we locate negative 5 here. And now we're just going to count out the slope using the scale, of course. And so we're going to go from negative 5, we're going to go down 1, 2, 3, and then we're going to run to the right 1 here. And there's the next point on the line, because from starting with the y-intercept where the graph crosses the y-axis at 0 and -5. We know that the next point of the line, well, the line follows the slope of -3/1. And so from here, we're just going to draw the line that will follow that trend. And so we start at the y-intercept of 0, -5, and we're going to go down 3 to the right 1, and then we'll go up in the opposite direction. If I can get this right. And so that's going to be the line. I would, if I were drawing it on paper and pencil, I would just use a ruler and just kind of go right through and extend both sides. But in this case, I have to do it from one side to the next just to try to get a little bit of accuracy and precision. Moving right along here, so now we've got -10 plus 2/3 x. Again, same sort of idea. What I'd like you to do is pause the video and see if you can graph this on your own. Take a look at the equation and determine what's the y-intercept and where is it, and what's the slope. And starting with the y-intercept, how would you get to the next point on the line, and then draw the graph. Okay, so hopefully you would have paused the video and have done that now. So I'm going to show here that, yes, we have, again, y equals b plus mx. Okay, the y-intercept is -10. The slope is +2/3. And so now we just have to plot the points and then count out the slope from there using the scale of the graph. So -10 is the y-intercept. So we're going to start down here. Y-intercept, which has the coordinates 0, -10. And then we know the slope is 2/3. So the rise is 2, the run is 3. So I'm going to rise 2 units, 1, 2. So I'm going up, and I'm going to run 3 units, 1, 2, 3. There's going to be the next point on the line. And if I want to, I could rise another 2, 1, 2, run another 3, 1, 2, 3, and there will be the next point on the line. So I could just continue doing that. You don't need to. You only need basically 1 point. Generally, I try to get a little bit more separation between the points to make a more precise graph. So I'm going to draw the line here and extend it past the points that I know. And then I'm going to do the same thing here. Try to follow the same trend if I can. And that is basically that for the line. Let's move this down a bit. Here we go. Okay, so there is the line, as accurate as I can do it in at this time, but that's how we would draw this graph. Moving along to this next one. Okay, so now this is a different form. This is actually in intercept form. So it's not in slope intercept form. This is called intercept form, where we can do a little bit of math here to figure out what the x and y intercepts are. Okay, and so recall that from one of the last videos that we did, the x value of any point along the y-axis is going to be 0, and the y value for any point along the x-axis is going to be 0. Okay, so this is where y equals 0. So the x-axis is where y equals 0, and the y-axis is where x equals 0. Okay, so if I want to find the x-intercept, then that means is where the graph crosses the x-axis. I know that y is going to be 0 at that point. So if I take the equation, 2.9x plus 1.4y equals 42, if I substitute y equals 0 into that, well, then I know 1.4 times 0 is just 0, and 2.8x plus 0 is still just going to be 2.8x. So I can just ignore that second term now, and 2.8x equals 42. And then in order to determine this, I know that there's no sign between the 2.8 and the x there. And so if I can, if I know that's multiplication, then I know in order to isolate the x, I need to divide 2.8 on both sides. And 2.8 over 2.8 as a fraction, that just equals 1. So I'm just left with 1x. So x equals, and then 42 divided by 2.8 is 15. Okay, I use my calculator for that, of course. And so the x-intercept then is going to be 15, 0. Okay, because we know that the y value on the x-axis is 0. Then if I go to here, the y-intercept, well, anywhere along the y-intercept, I know that x equals 0, so I'm setting x equal to 0. And then when I substitute x equals 0 into here, 2.8 multiplied by 0 is just 0, and 0 plus 1.4y is still just going to be 1.4y. And so 1.4y equals 42. 1.4y indicates as 1.4 multiplied by y. And so in order to isolate the y, I'm going to divide both sides by 1.4. And 1.4 divided by 1.4 just leaves you with 1. So we're just left with y equals, and then 42 divided by 1.4 is going to be equal to 30. So then that means that the y-intercept is going to be 0, because we know that x equals 0 and 30. So these are the 2 points that we know on the graph. And so we can plot those 2 points. So 15, 0 and 0, 30. So 0, 30 is going to be the y-intercept, and that goes right here. And 15, 0 is the x-intercept, and that's going to go right here. And so now, well, I've got a bit of a task to try to graph this appropriately. So I'm going to start with this. And so I'm going to kind of estimate where this is going to be, and then I'm going to have to adjust it. So the graph's going to go something like this. It's going to go through 15, 0. And then it's also going to go up here, follow here through 30. Okay, so that is going to be the graph. That's how you graph this equation using intercepts. 2.8x plus 1.4y equals 42. Okay, and that's what the graph will look like. Generally, I'm a little bit off here, but on paper and pencil, you can use a ruler and kind of just draw the line straight through there. Okay, so that's how we draw a graph in intercept form. Okay, and then now that we've done a little bit of graphing, now we want to take a look and say, well, okay, well, what happens here if we're given a graph? And these should have arrowheads here. I had to cut the graph off. So this graph goes on forever. I find it easiest just to use y equals b plus mx form. And then I can determine the equation of this line in that form. And then later on, we can change the different forms of it. So y equals b plus mx, we know b is the y-intercept. We can identify the y-intercept by looking at the y-axis, and we see that the graph crosses right here. And then we have to use the scale. So we have to kind of see, okay, well, make sure that what that value is. And actually, as I see that, that is the value of 0, 6. So the equation equals 0 equals 6 plus something x. Okay, and then we just have to figure out the graph and or the slope. Now, what I want to highlight here is that there are many places where the graph itself does not cross grid lines perfectly. So notice here, right here, is going through a vertical grid line, but it doesn't go through a horizontal grid line perfectly. And same thing here, it doesn't go through perfectly, or here, etc. Okay, we're saying that there's lots of places where the graph does not go through the intersection of grid lines. So you're going to be left with sort of estimating what the graph, what the value is going to be. But what I do see is here, the graph does cross through the grid lines perfectly, right where the two grid lines will intersect. And same thing here, and same thing here. So we can use any one of these, and this is also a place where it crosses perfectly. Okay, so I can use any one of those green dots in order to draw the legs of my rate triangle. Okay, and so I'm going to make one a little bit bigger just so we can see it a little bit. So I'm going to go from here and I'm going to go down here right to there, because I see that it's going to cross the grid lines perfectly there, and then I'll kind of draw this over here. So there's my rate triangle, and I notice that for the vertical, the change in y, the rise, well, I see that the graph is going down to the right. So that means that the slope is going to be negative. So I know I've gone from 0.6, I've gone down to 0.3, so I've gone down 3 here. Okay, and at the same time that I've done my rise of -3, I'm going to look at the run, and I'm going to start here. I'm going to go, well, we've gone over 1, 2, 3, 4, 5, 6. So there's a run of 6 units. Okay, so then I know that the slope, being that it's rise over run, or delta y over delta x, I know the slope is -3 over 6. And then I'm just going to simplify that by reducing as much as I can, and I see that that's -1 over 2. Okay, so then the slope up here is going to be -1 over 2. I'm going to get rid of this plus sign and just replace it with a negative, because I know that a positive multiplied by a negative is a negative, and so I'm left with 6 minus 1/2 x. So that's the equation of this line. Okay, so 6 is the y-intercept, and the slope is -1/2, meaning we go down 1 unit for every 2 units we go to the right. Down 1, 2 to the right. Down 1, 2 to the right. Okay, and then because it is a line, that rate of change, or that slope, is going to be consistent and constant all the way along the line. Okay, so I'm confident that that would be the equation of that line. Okay, and just one more quickly here. We've got another line here, and so I'm going to do the same thing. I'm going to use y equals b plus mx. And so I look for the y-intercept, and the y-intercept is going to be right here. So there's the y-intercept. Look at the scale. I see that we've got 5 lines, or 5 spaces between 0 and -10, 5 again here. So that means that every space must be worth 2. So this is actually going to be 0, -24. That's the y-intercept. So I'm going to start off with y equals -24. And then it's going to be plus some slope multiplied by x. And then I see that the graph is going up to the right, which means that the slope has to be positive. And again, I'm going to be looking, and I have to look very, very carefully as to where the graph crosses grid lines perfectly. Okay, so it doesn't cross perfectly there. And if I look really, really carefully, it does not cross perfectly there, or here, but there it does. Okay, it does cross perfectly right there. It doesn't cross perfectly here, or here, or here, or here, but then again, here it does cross perfectly again. Okay, so then I'm not guessing as to what the values are. I'm not using decimal values for my rate triangle, or for my values of delta y and delta x. So I'm going to use the second one again. So there's the rise for the rate triangle. Here's the run for the rate triangle. And then we're going to count out the values. So we're going up 2, 4, 6, 8. So there's a rise of 8 here. Okay, so that's the delta y of rise of 8. And here we're going over 2, 4, 6, 8, 10, going all the way to 20 actually. So that's a run of 20. That's the delta x. So then my slope of my line is rise over run, which is 8 over 20. And then I can simplify that, divide top and bottom by 4, I suppose. So I get 2 over 5. Okay, I prefer to keep things in fraction form as opposed to decimals, because then I always know what the rise is and what the run is just by looking at the fraction. Okay, and then that makes me pretty confident that 0, -24 is the y-intercept, and the slope is 2 over 5 and is positive because it's going up to the right. Therefore, I'm confident that that is the equation of the line. So that's a little bit of graphing practice, graphing and determining equations of lines from graphs. And so hopefully you can continue practicing that. Thanks for watching, and we'll see you in the next video.